1,000 years, the area has changed enormously. Originally, the castle would have been on the coast. Then, longshore drift and deposition has created a spit across the estuary mouth. Material trapped behind the spit has formed a marsh. Saltwater-tolerant plants have grown, trapping more sediment, and the area has turned from marsh into land.
Today, the castle is high and dry, nearly a kilometre away from the sea. In between are sand dunes, a golf course, houses and a caravan park. If he were alive today, King Edward I, the guy who had the castle built, would not believe his eyes.
The Kaitareiti Spit, a nearly 30-kilometre-long deposit of cobbles and shingle, is one of the most fascinating landforms on New Zealand's coastline. The story of how the spit came about is tightly bound up with the story of many other landforms in the region. The formation of the spit is, in fact, the last of many events that, together, have produced the look of the landscape as it is today. To cover these events, the best thing to do is a lightning tour of the area's physical geography and squeeze quite a few millions of years into a matter of minutes.
The lightning tour starts right here, where one of a number of extinct volcanoes meet the sea. And it'll also finish right here, in just about 2 minutes' time.
100 million years ago, no spit, no plains, no volcanoes, no mountains. Then, 26 million years ago, two plates collided and the New Zealand Alps were thrust up. Another plate movement caused lots of earthquakes and the volcanoes sprouted. 2 million years ago, the temperature dropped and New Zealand got its ice age. 12,000 years ago, the ice melted and left behind thick deposits of drift that became the plains and the coast itself.
A coastline made of glacial drift, absolutely typical of much of New Zealand's South Island, and eroding, as you can see, pretty fast. But that's not the end of the lightning tour. There's another process going on here that completes the picture: longshore drift.
As always with longshore drift, material eroded from the cliffs gets transported along the coast in the direction of wave attack. If there's a bend in the coast, the material carries on, forming a spit, the Kaitareiti Spit.
The spit has now grown to a total length of 26 kilometres, and at this spot we're almost at that distance from its root, back there. And the last 500 metres of the spit run straight into the old volcanoes, where we started the tour.
The spit is a perfect reminder of a crucial fact about physical geography. Although it often doesn't look like it, landforms are always changing and on the move. Rocks actually travel. Those on the Kaitareiti Spit are mainly a rock with the strange name of Greywacke, exactly the same rock from which the New Zealand Alps were formed. It's interesting to imagine what kind of a journey a single lump of Greywacke might have made.
It could have been shaken off the top of a mountain by an earthquake, then brought down in a landslide, then carried down the mountain in a glacier, then picked up by a river and brought to the sea, then transported by longshore drift from 100 kilometres back there. It's a very New Zealand story.
We're at about 43 degrees south latitude, well inside the belt of westerly winds that blows around the whole of the southern hemisphere. The weather pattern predicted for today is an extremely common one around here. There's a mass of warm air due to move in off the sea from the northwest.
As this warm air moves away from the sea towards the mountains, something crucial will happen to it. Let's take a volume of this air. You can't see it, but it has water in it, in the form of vapour. How much vapour depends on the air temperature. This mass of warm air at 30 degrees can hold around 15 grams of water vapour in every kilogram of air. When the temperature of a volume of air goes down beyond a certain point, the water vapour condenses into water droplets. The droplets form around specks of dust or around specks of salt picked up from the sea. We can then see the water as clouds. And when the droplets grow large enough, they fall as rain. On New Zealand's South Island, this whole process happens as the warm air rises and cools against the windward side of the mountains. 2 or 3 times a week, you can see it with your own eyes. This is temperate rainforest, one of the rarest vegetation types in the world today.
This lush environment not only has a very special look to it, it also has an unmistakable smell of damp humidity and rotting vegetation, all thanks to a particular kind of rainfall produced by mountains in the path of the westerly winds.
In these conditions, there's always a huge difference between the rainfall on the windward side of a mountain range and on the other side, the leeward. It happens worldwide where mountains stand in the way of the westerly winds in the temperate latitudes.
It's still the same latitude, 43 degrees south, but the rainfall's dropped to just 10% of what it was on the other side.
It's another hot, sunny morning in Costa Rica, but already the clouds are starting to gather.
According to the locals, one of these is just as important as sunblock. In fact, they have a saying, the hotter it is, then the harder it will rain.
That's because the weather patterns here are dominated by convectional rain. It's another way in which air is lifted and cooled. When the ground gets intensely heated by the sun, the warm air rises. As it does so, it cools and the water vapour condenses. Clouds are formed, eventually leading to rain. Convectional rain doesn't just happen in the tropics. It often occurs in temperate latitudes, like Europe during high summer, creating some familiar scenes. Frontal rain has to do with one of these things. It's a depression, one of the most common features on UK weather maps. The lines and symbols don't really give much of an idea of how it's formed or what it's doing, so here's World Physical's simplified, step-by-step guide to what happens. The UK lies on the boundary between cool air from the Arctic and warm air from the humid tropics. The boundary moves around according to the time of year and the prevailing weather conditions. There's one kind of move on the boundary, though, that actually kicks off a depression. It's when a wedge of warm air forces its way into the cold. The wedge is shown like this on a weather map. The 2 lines mark the boundary between the warm air and the cold air. They're known as fronts. The wedge, or depression, is moving all the time, and most of the ones that affect the UK move from west to east. The leading front is known as the warm front because it has warm air behind it. The second line is called the cold front because it has cold air behind it. Along both fronts, warm, humid air is cooled by contact with the cold air. The water vapour in it is condensed into moisture and falls as rain. This means we get two bands of rain as a depression moves through. These usually take between 1 and 3 days to pass over, and the UK is affected by around 100 of them every year. It's 2 o'clock in the afternoon. All morning the clouds have been gathering over the rainforest in Costa Rica, and now it's time for the daily downpour. Tropical rainforests can be found in a narrow band around the world that extends 10 degrees north and south of the equator. What distinguishes them from other types of forest is the amount of rain they receive. Here, on the east side of Costa Rica, the average annual rainfall is 4,500 millimetres. 3 factors contribute to this deluge. Firstly, the Caribbean Sea is a constant source of warm, moist air. The prevailing easterly winds blow this air onshore, resupplying the rainforest with moisture. Secondly, the moisture can't be blown further west because of the mountain ranges running down the middle of Central America. It remains trapped over the rainforest. The third factor is the forest itself. Taken as a whole, the rainforest is a complex living organism which has a range of ways of sustaining itself. After it has rained, the forest returns moisture to the air in 2 ways: evaporation and transpiration. The transpiration part, which is where plants sweat because of the warmth of the forest, is so dramatic that it generates 50% of the rain falling back into the rainforest, an amazing natural example of water conservation. As well as controlling its water intake, the forest also has a number of ways of maintaining its food supply and ensuring regrowth. It even protects itself against sunburn.
It's mid-afternoon and the rain's let up a bit. The sun's still high in the sky, but it's really dark down here. You can see what a difference this torch makes. The reason it's so dark is because there's still heavy cloud cover, but it's this cloud cover that helps maintain the rainforest. Without it, it would be exposed to the full intensity of the equatorial sun. As it is, it typically gets 4 to 6 hours of sunlight a day, enough to stimulate growth, but not so much it damages this fragile ecosystem.
Several different systems contribute to the health of the rainforest, and they all depend on one another. To understand how they work, it's best to imagine the rainforest as a number of layers, starting with the ground layer and ending with the top layer or canopy. The ground layer consists of the soil and all the material lying on top of it. This includes many fallen trees, whose exposed roots reveal a lot about the underlying earth.
You'd have thought with all this lush vegetation around us, you'd have a really rich soil. But this tree's roots tell us a different story. They grow out sideways, but hardly down at all. That's because the soil here is really very poor. What little nutrients there are only held in the top few centimetres.
This is due to the way in which the forest recycles its nutrients. All the dead material lying on the ground is swiftly broken down by insects and fungi to form a thin layer of topsoil. But the process doesn't stop there. The nutrients are quickly soaked up by the surrounding trees, which means they never have a chance to penetrate any deeper into the ground. As a result, the subsoil is pretty infertile. This process is so fast at recycling material that, unlike most other parts of the world, nearly all of the nutrients in the rainforest are held in the trees rather than the soil. The next layer up is mainly populated with shrubs and young saplings. This part of the forest is usually quite dark because it lies in the shadow of the trees above. But every so often a tree comes crashing down, opening up a gap above. Light comes streaming in to stimulate growth. And that's not all that happens. The growth spurt is the beginning of a huge fight between different plants to see which one can make best use of the conditions. The competition for growth is so fierce that only one seed in 10 million will produce a tree that reaches the canopy. And the battle is being fought out by an incredible number of combatants.
Walking through the rainforest, it's actually quite difficult to find two trees the same. There's an incredible diversity of plant and animal species, which is why the rainforest is so special. In fact, scientists have calculated we know more about the surface of the moon than we do the species of the rainforest.
In the next layer up, the undercanopy, the competition becomes even more intense. Delicate palms compete with thick, heavy vines for space. And some plants start life by growing on top of others. These are epiphytes, or air plants, which start life in the boughs of trees. To begin with, they don't need roots because they take in water and nutrients straight off their hosts. As they get bigger, they frequently extend roots to the ground to supplement their nutrient intake. As if having to share their supplies with an epiphyte wasn't bad enough, some trees may find themselves in the clutches of a killer. This is a matapalo, or strangler fig. As it grows, it slowly wraps itself around its host tree, gradually cutting the trunk off from light and water.
In the middle of all this is a laurel tree which has all but disappeared in the clutches of the fig tree that's growing on it. It won't be long before the fig surrounds the laurel completely and kills it. Eventually, only the fig will remain.
Several tree types have developed ways of defending themselves against the attention of epiphytes. This one has a very smooth bark, which makes it very difficult for epiphytes to get a grip. Those species that survive this long may achieve the ultimate prize. They reach the canopy, the top layer. Some, known as emergents, even shoot out above the canopy, but all can now benefit from direct access to the sunlight and rain they need to survive.
I'm on a special aerial tramway which gives me a really unique view of the canopy. 80% of life in the rainforest is found up here. The trees are dripping with epiphytes and rotting vegetation. Compared to the forest floor, it's really very bright. It's these conditions that allow such a diversity of life to flourish.
There's one other process going on throughout the rainforest that life here depends on. And it's not just the forest that benefits. All life on Earth relies on this process taking place. The forest takes in carbon dioxide through leaves and, using the heat from the sun, combines it with water to make the energy it needs. The byproduct of this process is oxygen, which the forest releases into the atmosphere. It is in fact the air that we breathe.
Although all forests convert carbon dioxide to oxygen, the rainforest does this particularly efficiently. But they depend on a very fine balance between many elements: rainfall, the soil, and sunlight to ensure their survival. Even a small change in this fragile balance can threaten their existence, and that would have a knock-on effect for everyone, all around the world.
Dawn breaks over the Sonoran Desert in the American Southwest. Even now, in the middle of autumn, the temperature will shoot up to 30 degrees centigrade as the sun beats down relentlessly. Deserts come in all shapes and sizes. Some are hot, some cold. Some are devoid of vegetation, and some, like the Sonoran Desert, are surprisingly green. But what actually is a desert?
Deserts all over the world, whether hot or cold, have one thing in common: a lack of water. The Sonoran Desert gets less than 200 millimeters of rainfall every year, which is nothing. And that makes it a very harsh environment for life to exist in.
The Sonoran Desert is big, about the same size as England, and the reason it gets so little rain is because of its geography. The Pacific Ocean lies just to the west, but the coastal mountain ranges effectively stop most moisture reaching inland. To the southeast lies the Gulf of Mexico. Any moisture from there must travel 1,700 kilometers and cross the continental divide before it reaches the Sonoran Desert. All in all, it's a difficult place for moisture to reach. Forecasting weather in the desert, therefore, is usually pretty easy. Sunny with blue skies. Clouds rarely form because there's so little moisture around, and the dry air sucks water out of the landscape, contributing to the harsh conditions. And yet more than 2,000 species of plants can be found here, from legume trees to rare lilies, and the desert supports a surprising diversity of life.
Despite the lack of water, some parts of the desert are incredibly green. That's because many of the plants that grow here are zoophytes, plants which have adapted to the harsh environment by making the most of what little water they receive. One of the most successful ones is this giant cactus, the saguaro. They only grow in the Sonoran Desert, which is an indication of how specialized they are. When it rains, they collect water using their spines and a horizontal web of roots. The bulk of that water is then stored in the stem to sustain the cactus until the next rains come. Incredibly, the saguaro can lose up to 82% of its water before it dies of dehydration.
Like most plants in the desert, saguaros live for a long time, typically 200 years. They grow incredibly slowly, taking 10 years to grow just a metre. However, fully grown, they can reach 18 metres in height and will have developed a number of arms. Saguaros are only found in certain parts of the desert. At altitudes of more than 1,500 metres, the nighttime temperatures can drop well below zero, and the cacti would freeze. And just as they disappear when too cold, they also disappear if it's too dry. So they're rarely found in the centre of the desert, where air temperatures can reach 50 degrees centigrade and less than 100 millimetres of rain falls a year. Out here, other types of vegetation dominate the landscape.
One of the most successful plants down here on the plains is this, the creosote bush. The roots reach down vertically and out horizontally to grab as much water as they can. The leaves have a type of varnish on them to seal in moisture, and the smell and the taste of the creosote puts off any animals from trying to eat it. The creosote bush is so successful at surviving in this environment that they can live for up to 12,000 years.
Another hardy desert plant is the ocotillo. It looks dead, but in fact it's waiting for the rain to come. In the desert, this happens in two distinct seasons. In the winter, cold, wet fronts from the Pacific are sometimes strong enough to bring rain to the desert despite the intervening mountains. And in the late summer, warm, wet air from the Gulf of Mexico sometimes makes it over the continental divide and is swept in over the desert, often forming thunderstorms. The rainfall can be intense, turning dry gullies into flooding rivers in a matter of hours. When it does come, the desert turns green as if by magic. The Ocotillo, having waited for so long, bursts into life. But after a few days, the Ocotillo will shed its leaves and hibernate until the next rains. Rainwater runoff is one of the factors that erodes the desert. But the main one is wind. Strong winds strip away any loose sand and soil, slowly changing the shape of the ground.
You can see here how the wind has shaped the desert. These plants have secured the soil around them, but on either side the wind has blown away any loose material, lowering the surface. What's left are just pebbles forming a brittle desert pavement. It's so fragile that even my footsteps could break up the surface enough to allow the wind to erode it further.
Although the desert soil is fragile, it's far from useless.
Looking around at the sparse vegetation, you might think that the soil here was very poor. In fact, the opposite is true. It's very rich in nitrogen compounds and mineral deposits.
The sparse vegetation and dry conditions mean there is little or no humus layer in the desert. However, the soil does have a thick layer of mineral-rich subsoil sitting on top of the bedrock.
Minerals end up in the soil from rotting vegetation like this. And because there's so little rainfall, material builds up over time rather than getting washed away. The result is a soil in which you can grow almost anything, so long as you've got some water.
But this part of the desert only gets 10 days of rain every year. It may be many more days before the winter rains come. Kalimantan in Indonesia is home to some of the oldest tropical rainforests in the world. Hidden within them is a huge diversity of animal and plant species, many of which have yet to be identified properly. In fact, scientists estimate we know more about the surface of the moon than we do about life in the rainforest. What we do know is that places like Kalimantan are full of valuable trees and plants. And in common with every other resource on the planet, people have not been slow to exploit the forest's wealth. During the last decade, the rainforest has been cut down faster in Kalimantan than anywhere else on Earth, all because of people's greed. The forests were controlled by a small group of timber barons. They had close friends in the government and were allowed to do what they liked with the forests. The temptation was too much to resist. They decided to make themselves incredibly rich by chopping down millions of trees for timber. Enormous areas were cleared, turning parts of the forest into a kind of desert. They didn't just cut down the trees. In an effort to turn parts of the forest into large farms, vast areas were set alight. Trees, animals, and plants were all wiped out by the flames. The fires burned for weeks. The timber barons were so powerful, no one could stop them. Once the fields were cleared, they planted crops and waited for the harvest. But the crops failed. Removing the trees had changed completely the way the land worked. With no roots to hold the soil in place, all the topsoil was washed away by heavy rain. Huge areas of land had been ruined for nothing. The forest will take decades to recover, if it ever does. Rainforests all over the world have suffered the same fate. treasure troves, which have been plundered and left to waste. But elsewhere in the world, some people are starting to work with the forest rather than trying to dominate it. On the other side of the Pacific from Kalimantan lies Costa Rica. Until recently, it led the world in deforestation. But now, most of the remaining parts of the Costa Rican rainforest have been turned into national parks, protecting them against further exploitation. And the local people are finding ways to earn a living from the trees without cutting them down. One way they're doing it is by turning the forests into a tourist attraction. Small groups pay for guides to show them the wonders of this tropical paradise. However, small-scale tourism only brings in a small return, and large-scale tourism would risk destroying the very environment people have come to see. So this can't be the only answer. In the Talamanca region of Costa Rica, people are trying to find ways of farming the forest in a sustainable and profitable way. Having worked as a forester in central Costa Rica, Luis Rodriguez wanted to experiment with ways of farming in the rainforest. When the opportunity came, he bought a farm on the edge of the forest, but he knew it was going to be a challenge.
This farm was severely degraded when we came. All of the trees had been chopped down. There were places in the farm where I found no vegetation at all, which is very rare in the tropics.
Instead of trying to plant a new crop, Luis let the surrounding forest grow onto his land naturally. Then he copied the way the rainforest develops by planting various different crops amongst the trees. Now, 10 years after he started, Luis's farm is thriving. It supplies more than enough produce to feed his family, but Luis also grows several crops that he sells as high-value organic produce. Every 2 weeks, a crop of bananas is ready to be harvested. And once a year, there's the valuable crop of cocoa, the basic ingredient for chocolate, to take in. And finally, he can chop down the odd tree now and again without spoiling the balance of the farm. His approach seems to be working. In contrast with his neighbours, Luis and his family live in a big house with modern conveniences like a television and a computer, and the rewards aren't just financial.
We live in a fantastic environment, coexisting with all kinds of plants and animals. That gives us a lot of satisfaction, because having started with a barren farm and having worked so hard to improve it, my dream is becoming reality.
Farming isn't the only way the local people are making money from conserving the forest. Guillermo Moro works for a local forestry organisation which is developing some innovative and sustainable forestry techniques. Instead of cutting trees down, they actively seek out ones which have fallen down naturally. The next step is to turn the tree trunk into several logs. But the logs aren't much good stuck in the forest. They still have to be moved to where they can be of use. That's where Guillermo's secret weapon comes in.